Alright, so here's example 2. Two different dice are rolled simultaneously, and the keyword here is different, and what this means in this context, I will explain it later. Find the probability that the two dice will show the same face or the same number, and for part B, John rolls both dice exactly 36 times. Find the expected number of times that in each roll, both dice do not show the same face or same number. Right, what it means by these dice are different is as so. Assume we call the first dice dice A and the second dice dice B. Assume that dice A shows number 1 and dice B shows the number 2. This is completely different from the combination that dice A shows 2 and dice B shows 1. So these are different combinations. So what it means by different. So and usually if both dice are almost identical and they have the same color, it would not be differable. And what that means is that you cannot like differentiate which one is the first dice or which one is the second dice. So it's kind of hard. But in this question, it says assume that we can differentiate between which one is the first dice and which one is the second dice, so that we can form different combinations that look similar in order. Alright, so that's a brief explanation of that. Alright, now for part A. Find the probability that two dice will show the same face or same number. Now, we can write all combinations of both dice showing the same face or same number, and that will be first dice showing 1, second dice showing 1, and first dice showing 2 and second dice showing 2, and so on until first dice shows 6, second dice shows 6. And we're writing this in order pairs such that the first input right here will show dice A and second input would show dice B. So here we have 6 different ways or possibilities. Alright, so let's just write the probability right here. So our probability will be 6 over the total number of combinations. And that would be kind of challenging if some of you are not familiar with combinatorics. However, we can actually find that by using logic. So to find all combinations, let's just suppose that dice A shows a number of 1. Now since we were finding all possible combinations, we can set dice B to be any number, to show any number from 1 to 6. So from our first column or first row, we have 6 combinations. We can do the same for A showing a number of 2. We can set B to be any number from 1 to 6, again leaving us with 6 combinations. You can do this all the way until you arrive at 6, which is the maximum possible value for a dice to show a number of. And then we can just add up all these numbers of ways. So the total number of ways will be 6 plus 6 plus 6 plus 6 plus 6 plus 6. That will be 6 times, or 6 plus 6, which will be 36. Alright, so we can fill the denominator with 36. Simplifying this, we get a probability of 1/6. For part 2, John rolls both dice exactly 36 times. Now we need to find the probability that both dice do not show the same face or same number. Alright, so the probability that it shows the not same number although I didn't mention this in my first video of the explanation, but there is actually a formula for this. So I'll just write it for you guys. So a probability of an event happening is actually equal to 1 minus the probability of that same event not happening, which is sometimes denoted by this. It's sometimes called A accent or A complementary, or probably any other way uh you would pronounce that. And we can actually switch both faces so that it forms another equation similar to the first one. And this logically makes sense because if the probability of an event happening is some number, then the probability of that same event not happening will be 1 minus the probability of that same event happening. Alright, so let's just use that. So it will be 1 minus the probability that it shows the same number. So that's the complementary of this event right here. That will be 1 minus 1 over 6 or 5 over 6. So therefore our expected frequency that it shows the same number will be the number of trials times the probability, in this case 36 times 5 over 6, which will be 30. And that finishes the second example.